Good morning and welcome to the 21st annual exhibit of hydrogen and fuel cell technology and batteries. We are always discussing developments that are on the forefront of applications, how to use this technology, how to spread it around the globe. We'll be talking to a specialist in this field who works with electrolysis. It's Alberto Carpita, who is Sales and Marketing Manager for Heliocentris in Italy. Welcome, Alberto.
Good morning, Brian.
Good morning. So, we get to have a seat. I suppose first on the list is simply a profile, Heliocentris. Where is it located and what do people do?
Yeah, we are located as headquarters in Berlin, but we have many other offices in Germany as well, Munich, Stuttgart, but also in Italy, in China, Yangon, in South Africa, Johannesburg, and maybe I'm forgetting someone, maybe Kuala Lumpur. So it's a German company, but looks definitely worldwide market.
So a global company, and your key technology, your focus, I would say historically perhaps, has it always been electrolyzers?
As Heliocentris, it has been founded in 1995. So it has quite a long history, and it started looking at fuel cell technology, but then it developed more the concept of providing power as a solution, and actually it has a list of proprietary technologies that are going to the energy management and the connection of the sites with a unique software that allows to manage the single sites very easily, but it is really it has in its roots the hydrogen technology, because we believe that it will be definitely the future, but also a very nice present. And it is why recently acquired the Futury, a fuel cell company based in Stuttgart, and recently also cooperating with ACTA based in Italy, and ACTA has been the company that firstly developed the AEM Electrolyzers technology.
So that's a very broad spectrum and a very international profile. It's always interesting to have some examples of where you've got your technology up and running. And I know there's some wonderful global examples. Perhaps we could talk about what you do in Thailand, start with that.
Yeah, thank you. We have also some nice pictures from our applications. The AEM technology is a technology that is a low temperature electrolysis technology that has many advantages, and these advantages are really important to allow on-site hydrogen generation, also in small sites in an efficient way, but mostly important in a way that is compatible with the real in-field conditions. So it is why we have been able to have those applications in field in which we store the hydrogen to use it back for electricity production, but also heating. And in Thailand, we started in 2013 a project that now accounts 100 kilowatt PV power that provides the entire energy for a residential complex. And they completely rely on the energy they get from the sun. And it is possible, thanks to this hybrid concept of energy storage with hydrogen and batteries, but in which the hydrogen plays really the main role, providing a very green and clean solution. So harvesting the energy from the sun, completely carbon-free, and handling this energy in the most green way as possible.
And this has always been the energy owner's dream, actually. The vision of fuel cell technology is simply that: 100% renewable energy, using electrolysis to store that energy in the form of hydrogen and giving it back when it's needed. You've got Thailand, of course, has its own specific conditions there. They may be optimal or suboptimal, but you also work in other climates, don't you?
Yeah, we do. So, very different climates. And I would say we can start from installation we performed last year in the French Alps. So, very harsh conditions because the installation it is in top of a mountain for a very small village, and it is 2,600 meters high. So very harsh conditions, especially during the winter. And there, the role of the electrolyzer is to harvest the energy from the PV all over the winter, and then provide uninterruptible power through fuel cells during the summer to this small village. So in this way, this small village can rely on all year round very green energy, carbon-free energy. It is actually in a national park, so it was important to have a green solution. But it's not just the green side of this technology that makes it important, but it is also economically efficient because the stored hydrogen doesn't know any depletion over the time. So you well know that if you have a charged battery, over the time you have a depletion of the charge. It doesn't happen with a stored compressed hydrogen. So when you have 30 bar, 35 bar, or 50 bar in a compressed tank, you don't lose any kind of energy over the time. So the hydrogen that is contained in this tank stays over the time indefinitely.
That would be, of course, vital because, just to get this straight, they store up the energy during the entire winter and use it during the summer?
Right.
So, I mean, no batteries like to sit around doing nothing for half a year.
That's right. So you would lose a lot of energy along the way because, if you store energy in January and then you are going to use it in June, so over that time, a standard battery will lose a lot of charge, a lot of energy, and it does drive to a not efficient solution. This not happens with hydrogen.
So we have high altitude, which I find fascinating. Water boils at different temperatures up there, so there's other parameters involved. It works there. It works in Thailand where things are wet. Have you ever been to the desert with your technology?
Yeah, we have been in the desert in North Africa, power backup solution. So very, very warm, 50, 55 degrees of ambient temperature, very sandy and dirty. So it is a very important point, but also in the outback in Australia. So another very nice application, providing backup power to a base station of a main telco operator, and this backup power comes again from the sun completely. So we have in this national park in the outback a completely carbon-free solution to provide the power to the base station. And all those applications are possible thanks to the specific advantages of the AEM electrolyzers, because we don't need very controlled conditions like for the other technologies, because our technology is not really affected by the water conditions. Of course, we need the ionized water, but we have not really stringent requirements for the water treatment.
That's exactly the point I wanted to make here. We haven't even discussed the distinction between AEM electrolyzers and the standard PEM electrolyzers. So let's roll that back. We heard one already, impurity, but to stress that point, we're talking about PEM cells are notoriously fussy. They don't like contaminants, and it's a huge issue, of course, because platinum's very expensive. And the platinum catalyst can be wasted really quickly if you do something wrong, that is carbon poisoning or impurities in the water. It's a vital issue, which makes them less flexible or even more expensive to operate if you can change those factors. So, and that also, of course, increases the cost of the electrolysis if the initial investment involves a lot of platinum. So let's go through the cycle. The first question you already mentioned, it can deal with water that is less than pure, which is suboptimal for the PEM cell. What about the catalysts? How much platinum is there in the AEM system, the electrolyzers?
Basically, the AEM electrolyzers are able to run also without platinum at all.
Okay.
And the cost of the catalyst in general, it is just 5% of the total breakdown cost of the stack. So it is very different from PEM technologies, because for PEM technology you need a big amount of platinum, and so we know well a lot of people is really spending a lot of efforts to decrease this amount of platinum. It is a thing that we did for AEM, and it is why we can have a cost for this technology that is really competitive. And it is not just advantages in terms of less pure water allowed or the efficiency, but also the cost of this technology is really, really competitive.
Another question would be, of course, there's electrolysis for various applications. If you have a large client next door who needs large volumes, people can think differently. But for these remote applications, and I always call these the engineer's dream. Engineers love the story of Robinson Crusoe, because you land on an island and you have all the parameters in front of you. You can control them. There's no grid. But there are remote locations that are exactly like this, where you have to provide the initial source of energy. And some of the important points for applications there are, well, you know, there are SOECs. They run at high temperatures. They're very effective, but they have really long startup times. If you're trying to harvest the maximum quantity of wind, you have the turbines turning on and off. If the wind's blowing and then suddenly it stops and it starts again, long startup times incur huge losses. So it really is important. PEM technology is a low temperature technology, which means the startup time is briefer, and the operating parameters are closer to some environments. What about the AEM technology? Is it low temperature? What are the startup times like?
Yeah, the AEM technology is as well low temperature electrolysis. Basically, we start the production of hydrogen at 20 degrees. We can do that also at lower temperatures, but of course the efficiency is slightly lower, and we go up to 60 degrees. So the startup time is as brief as for PEM electrolyzers, and basically we can perform as PEM and also in efficiency. We have actually very good efficiencies, competitive, and I think in the same range better than PEM electrolyzers. So I don't want to say that AEM is today already a replacement of PEM technologies, but actually it is a very well complementary technology, because today we don't have the very big range of power that already the PEM technology achieved. But I think it is the point. So I see very well the PEM technology in very big applications, where you can have a very controlled environment, and you can let the PEM electrolyzer work fine. But I think for all those remote locations, and not only remote locations, but really in field conditions, you can have an AEM electrolyzer that really do the job very well.
I should add, if there are questions from the audience, you need only raise your hand. We have one question. I hope you don't mind.
No. Welcome.
Yeah, hello. That was very interesting topic, but I have one question. If you use the hydrogen fuel cells as a temporary storage for electrical energy for daily uses,
Yes.
can we talk about efficiency, how much we lose and how much we gain? Can you give us an idea? What kind of efficiency you expect?
Thank you very much for the question. So, talking about numbers, the efficiency of the stack, the AEM stack, is 90%, even higher. And the efficiency of the electrolyzer for 1 cubic meter already it is almost 80%. Of course, when you use a fuel cell, you don't use completely the energy, the chemical energy of the hydrogen, but you just use a part of this energy, and combined with the efficiency of the fuel cells that we can find in the market today, that basically are around 50%. The total round-trip efficiency of such a system on a daily basis is about 40%. So it can look a small number compared with, for example, lithium-ion batteries that have achieved 90% and even higher efficiencies. But if you consider the time in which you use this energy, and you consider also the depletion effect of the charge, you discover that the gap between the two efficiencies is not that high. But more important, the price per kilowatt hour of the stored energy for the compressed hydrogen is much lower than lithium-ion batteries. So, okay, we hear that lithium-ion batteries will have the price by 2020, 2025 of $200, $250, $300 per kilowatt hour, talking just about the cell, so without all the balance of plant. It is a price per kilowatt hour that for a kind of application that in which the AEM can really play a good role is already achieved. So, and I think that actually the best energy storage solution is an hybridization of batteries with hydrogen. So the battery used on a daily basis, and the hydrogen used to harvest energy and to provide it back in the long term. So really, I think it is the most effective way to use this technology.
I think that's a very important point because, of course, even where batteries are more effective, depending on the volumes as well, batteries are not plausible. It doesn't work. We have in Germany in the north a wonderful source of wind energy, and they're turning the turbines off. So if you use electrolysis to store that energy, you don't worry that much about efficiencies because you lose 100% if you don't do anything. And the battery solution doesn't work simply because there's terawatts. The batteries in that volume, and storing hydrogen is a lot more feasible. But that is the big solution. What I find so interesting is when I mentioned the wind energy source up at the north, this is a model for the centralized grid. The notion would be that you send all of that wind energy from the north all the way down to Bayern, and the grid, you lose 30% or more of that energy just transporting it. Centralized grids are not that effective. What I like about your solution, which I find so fascinating, is it allows scalable implementation to decentralize the grid, produce locally, and consume locally. Is that your business model for the future?
Right, correct. Yeah, really, you're right there. So we really believe, and we already having a lot of very, very good and promising feedback about having this solution implemented in many countries. Especially, we are here with a Japanese trading company, so Japan, of course, but all those countries in which we are going to see a very impressive growth in the renewable power installed. So all those countries are going to be a very good market for us.
Well, we'll have to hear next year from you how things are going. This has been a fascinating talk. It's a model for success, I believe, and we wish you all the best.
Thank you very much.
Thank you. I've been talking to Alberto Carpita, who's Sales and Marketing Manager for Heliocentris. The booth is right over there, and I'm sure you'd love to talk to people who have further questions right after this talk. So just follow Alberto in this direction. The booth number I don't have.
B59.
B59, right over there, and you may continue the conversation there. It's been a pleasure talking to you, Alberto. Thank you very much.
Thank you.
And thank you. We are continuing our talk in the next minute or so. Up next is Dr. Michael Klaschinski, who's from Experion Energy and Environment, and he'll be talking about hydrogen storage systems, another issue very related.